Okay, here we are. It's time to wrap up our discussion of polynomials. That's gone pretty quick, I feel like. Uh, Remember one thing as we get started in this final video, that polynomials is a huge topic that spans many levels of mathematics. And we are really just kind of scratching the surface. So when we're done with this video, you'll know some of the very basic information, but there's still a lot that you won't know. And so as you start working with problems, there might be times that you run into where you're like, well, I'm not sure about this part of the graph. When you run into those issues, don't worry about that. It's going to be very, very clear in just a second when we look at our learning objectives, the parts of the graph that you do need to know. Any other part of the graph, we're just going to assume that you're trying to get it close. And we're going to call it close good enough. Okay, so with that said, let's look at our learning objectives so you know which parts it is that you're supposed to try and capture correctly. All right, so as we learn about graphing polynomials today in this video, here's what we're going to focus on. You need to be able to find the x-intercepts of the polynomial that you're graphing. You need to be able to find the y-intercepts for any polynomial. Remember, a polynomial will only have one y-intercept. So plural here, there's only going to be one per graph, but you need to be able to find it for every graph. So I just want to make sure that we're clear, like, don't be on a wild goose chase looking for the second y-intercept. We talked about that with parabolas. There will always be one, and there will only be one. Okay, so that's good. Here's the one that might seem like it's new to us and behavior, but when we start talking about this, you're going to see that really this is something you already know from our discussion of lines and parabolas. We're just going to generalize it. And we're going to focus on the right-hand side of the graph. So that's called right-hand behavior. But we will talk about the left-hand side too. So these first two things you need to know pretty cold. The third one, you're going to, when we get to that, in fact, that's the first thing we're going to talk about, you'll see that you've got a pretty decent idea of this already. You'll get this pretty accurate. It doesn't have to be exact, but it'll be pretty accurate. And then notice our goal is just to sketch a possible graph. There's lots of things that are part of the graph that we haven't talked about here. And so keep that in mind. Okay, so we're going to begin by talking about end behavior, because the other two things we know. We know for x-intercepts, you're going to plug 0 in for y and solve. And we've been practicing that for a while now, so we know that. We know for y-intercepts, we're going to plug 0 in for x and simplify. Okay? And when you simplify, we know what's going to happen is you're just going to end up with a number at the end of your equation if it was in simplified function form to start with. Okay, so if it's not in simplified function form, well, maybe you have a little bit of work to do, but that's okay. So this is really the only one we don't know about. So here's what I've got. I've got a series of graphs that I'm just going to sketch a graph of a random function. And we're going to talk a little bit about what we notice in the graph. And we're going to start with lines and parabolas because we know about those already. And then I'm going to show you a cubic, so it just goes to the next level. And then we're going to kind of generalize what we're seeing here. Okay, so here's what I want to focus on. Is the first number of the line, or the first number of the parabola, or the first coefficient, the leading term, the leading coefficient, is it positive or is it negative? That's what we're going to focus on as we have this discussion. Okay, so is the leading term positive, or is the leading term negative? That's what we're going to focus on here. So when we have a positive slope, if we're talking about lines, the leading term defines the slope for us. When we have a positive slope, we know that means that the graph is rising as you move from left to right. That's what positive slopes do. And we know that when you have a negative slope, we know that the graph is falling as you move from left to right. That's what negative slopes do. These are things that we know because we've studied lines. Okay, so as I said, what I want to do in our discussion of end behavior is really start by focusing on the right-hand side and then go from there. Okay, so in this case, positive slope, right-hand side is going up. Negative slope, right-hand side is going down. Okay, now with the quadratic equations. If our leading term is positive, what we said in the last unit is that meant our parabola was shaped up like a cup. Up like a cup. So what does that mean about the right-hand side? Well, the right-hand side is rising again. Okay? What about when the leading term is negative? A is negative, okay? A is negative. All right. Well, what we said is the last section, that means the parabola is down like a frown. Down like a frown. So what's the right-hand side doing? It's going down again. Notice when you focus on just the right-hand side, for the line, it's going up. For the parabola, it's going up when the leading term is positive. For the line, if the leading term is negative, going down. With the parabola, going down. Okay, so notice they're the same. Now let's take a look at a cubic. This is the general, or I should say, this is the simplified function form for a cubic, not the factored form, the simplified function form for a cubic. My leading term is still called a, just like it is in the quadratic. This is not, by the way, something you need to memorize or anything like that. And this is not something that we're going to use with a formula like we did the quadratic formula. We're going to look at this right now for our discussion at this moment, and probably not again in our class. All right, so if that leading term is positive, now this is something that you don't need to know where this is coming from or why it's the way it is, but I'm going to draw a general cubic shape that has a positive leading term. A general positive leading term would be something that looks like this. Okay, it's a squiggly graph that potentially crosses the x-axis 3 times. That's what we're going to end up with, a squiggly graph that potentially crosses the axis 3 times. And if the leading term is negative, we'll also have a squiggly graph that potentially crosses the x-axis 3 times, but it'll look like this. All right, so again, I want to focus on that right-hand side for a second. When our leading term is positive, what's the right-hand side doing? It's still rising. When the leading term is negative, what's the right-hand side doing? It's still falling. Okay, so what we end up with is, in general, the right-hand side always acts the same. Whoops, scan out. Can I get it far enough that you can see all 3? I think I got them all. The right-hand side always acts the same. And it's exactly the same as what we've been learning since the very first day we started learning about slope. Positive slopes go up on the right-hand side. Positive parabolas go up on the right-hand side. Positive cubics go up on the right-hand side. And negative ones are doing the opposite. They're all going down. So that rule that you learned way back when for lines, the rule that we learned last week for parabolas, the rule that we're learning right now for cubics and beyond, this is for all polynomials. If we generalize that rule, it becomes the same for all of them, that when the leading coefficient, so the leading coefficient, if it's whether you call it m or whether you call it a or whatever you call it, when the leading coefficient is positive, the graph goes up on the right-hand side. So that's the first half of our rule. All right, and this is, like I said, I tend to focus on the right-hand behavior. That's what this is called, the right-hand behavior. So when the polynomial is simplified, right, standard function form. Remember, standard form, all the parentheses are removed, all the like terms are combined, our exponents go in order from biggest to smallest, okay, all that kind of stuff. Okay, when all that stuff is done, then if the leading term, leading coefficient is positive, the right-hand side of the graph will rise. the right-hand side of the graph will rise. And if it's negative, the right-hand side falls. If it's negative, the graph falls to the right. Okay, so if we focus on that right-hand side, we already know what it does. We're good. Okay. Now, here is the last thing that I want to mention. Well, what about the left-hand side? What about the left-hand side? Well, we're not going to go again into all the details with this, but here's the bottom line. The left-hand side is based on your exponents. If the exponent is odd, remember this is a sneaky ninja 1. This one down here is a 3. If the exponent is odd, the left-hand side does the opposite of the right-hand side. So here it's going up, here it's going down. Okay? Here it's going down, here it's going up. When you look at the cubic, here it's going up. There's some squiggles in the middle, but at the end, eventually it goes down. All right? Same thing here. Going down here, squiggles in the middle, but eventually when you get to the end, it starts going up. Okay? When it's even, the two will always match. Okay? Here it's going up, here it's going up. Here it's going down, there it's going down. Okay? When it's even, they will always match. If I had a 4th degree polynomial, so if I had y equals x to the 4th, something, 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 whatever, okay, that graph will potentially have squiggles in the middle. But if it's a positive a, my squiggles will go like that. Positive a going up on the right-hand side. That's our rule that we just wrote, going up on the right-hand side. But because it's even, left-hand side matches. It's also going up. Okay. If my a value is negative, then I would have a scenario that's the other way around. Negative a value, right-hand side goes down, squiggles in the middle, but eventually the left-hand side will go down too. They always match. Okay. So that becomes our rule. Now, like I said in our learning objectives, our focus for our class is to get the basic shape. And the basic shape that we're focusing on, find the x-intercepts, find the y-intercept, and get the end behavior, really focusing on the right-hand side with our rule here, but know the left-hand side, it's always going to match when the exponent is even, and it's always going to be the opposite when the exponent is odd. Okay, so I think that takes care of our end behavior. I believe it probably would be worth our while to make sure that we're clear on that rule. Okay, so make sure we're clear on that rule. Rule for end behavior. Okay, rule for end behavior, it has 2 parts. Part A is what we just wrote on that other piece of paper that I just moved. If the first term is positive, it goes up to the right. So I'm just going to abbreviate that here. A is positive, right? Numbers that are bigger than 0 are positive. Then it goes up on the right. And if A is negative, then it goes down on the right. Okay, so that's the first part of our rule. That's what we just wrote on the other piece of paper. Okay, so that's what we just wrote. Now, with part B, what I'm saying in part B is that we're looking at the exponent, the biggest exponent, the degree of the biggest exponent. If biggest exponent is even, then the right and left sides match. Like a parabola. But if the biggest exponent is odd, if the degree of the polynomial is odd, if the degree of the polynomial is odd, then the right and left sides are opposites, like a line. Okay. On a line, when the right-hand side is going up, the left-hand side is going down. Okay. On a parabola, when the right-hand side is going up, the left-hand side is too. All right. Now, the last thing that I want to mention again about the idea of just getting a possible graph, notice that none of our rules in here tell us anything about the squiggles in the middle. The squiggles in the middle is something that's beyond the scope of our class. That's more advanced than us, okay? So as long as you have the right-hand side going up when it's supposed to and going down when it's supposed to, and you can match up the left-hand side, and as long as you can find these intercepts, then that's going to be good enough. That's what we're looking for. So let's wrap this video up with a quick example. Actually, looking at the clock, I'm going to stop this video right here, give you a chance to take a break, organize your information, whatever. I'll make a second video that has an example of actually applying all of those things to create a possible graph. So thanks for watching this one. Make sure you watch the example video as well. Have a good one.